these are the solutions for test 2. So problem 1, we're supposed to find the moment of A due to F2. So I'm just gonna really quickly draw the beam and just that F2, because that's the only one that we're looking at here. So F2 is in this direction. It's 500 pounds, and it's a 3, 4, 5 triangle. And then point A is over here. So the moment about A, and if we do out of the page as being positive, the moment will be negative, because it'll be into the page, and it'll be, we want that vertical component of the 500 pounds, so 500 pounds times 4 over 5. And I forgot to write the distance. Let's see, this is 14 feet, so times that perpendicular distance. So grab my calculator. And we get 5,600 pound-feet, and it's negative. So negative means that it's in this direction, which is also can be written as clockwise. So it's 5,600 pound-feet clockwise, which was one of the options. For question 2, what was the moment about A due to force F3? So F3 was so we have the beam. Point A is up here. F3 was down here. 160 pounds. It's 30 degrees. And this whole beam is 19 feet. It's 8 plus 6 is 14 plus 5 is 19 feet. And then it also have this dimension here, which is 0.5 feet. So the moment about A is going to equal, we'll take the y component of the force, which would be 160 pounds times cosine of 30 degrees. And then we also have that y component, which is 160 pounds times sine of 30 degrees. So basically we get the moment about A is going to equal that 160 pounds cosine of 30 degrees. And that perpendicular distance is this whole 19 feet. And that's going to be in the negative direction. And then we also are going to have the moment due to this force that's 0.5 feet from there. And that's going to create a positive moment. So plus 160 pounds sine of 30 degrees times that perpendicular distance, which is 0.5 feet. So do the calculation. Negative 2,632.7 plus 40. And that gives us negative, let's see, 2,632, 40 minus 2592, and that's foot pounds. So 2592 foot pounds, and it's also in the clockwise direction. And that is one of the answers. Let's see. Oh, I guess I accidentally rounded. So this is actually 0.7, so it's really 2592.7, which is 2593. For the next one, you have to select which is the correct determinant to solve the moment about point P. So the moment about point P, this is question 3. Yeah. Color pen. Question 3, the moment about point P is going to equal the position vector from P to any point along that that line of action of that force. So we'll just do PA, because that's what we know something about, crossed with that force. We know the force, so we need to know that position vector from P to A, and that equals, so basically we're going to start at P and we need to get over to A. So we need to go 1 meter in the X direction, so 1I. We need to go -6 meters in the Y direction, -6J, and then we need to go up 3 meters in the K direction, plus 3K. And so that determinant is just going to be that I, J, K of R. So that 1, -6, 3, crossed with the F, which was given to us as -6I plus 4J plus 8K. So I just need to look closely through the solutions, and it looks like option 4 is the answer. For question 4, we're given the determinant, and we just have to solve that out. So the moment about O equals, so we didn't have to do all the heavy lifting there, I, J, K. And you could have done this in your calculator or by hand. But that's going to equal I times -16 minus 24 minus J times 8. J times 8 minus -36, so plus 36, plus K times 4 minus 12. That equals -40I minus 44J minus 8K. And that's kilonewtons times meters, and that corresponds with one of the answers for question 4. Question 5, so if you're drawing a free body diagram, which forces or moments would you need to use when you remove the roller at A? The answer for that one is it's a roller, so we know that it's just a perpendicular force. It's perpendicular to the surface, so it's just going to be AY. So you just select that one. For question 6, it's if you remove the pin at B, and we know with a pin we get 2 forces, so we'd have a BX and a BY. And so we'd select both of those options. Then they want us to replace the distributed load with a force. So for this one, this question 7, basically we've got this distributed load. I just broke it down into 2 areas. So we have the, like all the way across at 600 newtons per meter, we have a force. And this whole thing is 6 meters, and then half of it, so 3 meters. And then we also have a force from here down to that midpoint, a distributed force that's in a triangle shape. So I would just calculate both of those. So the big rectangle is going to be 600 newtons per meter times 6 meters. So that's going to give us 3,600 newtons. What's going on with my tablet here? 3,600 newtons. So meters cancel out, and that's going to be at 3 feet or at 3 meters. So at the center point, say 3 meters from A. A was over here. And then the triangle on top is going to be, so that goes from 850 down to 600 newtons per meter. So that's really 250 at the top end. So that's 250 newtons per meters. So that's at 850 minus 600. And then times 3 meters. And then times 1/2 because it's a triangle. So that's going to give us 750 divided by 2, which would be 375. 375 newtons. And that one would be at 1 meter from A. And so the total resultant force is going to equal that 3,600 plus 375. So that's going to equal 3,975 newtons. And then how far away would that force be? We can just do, we can sum the moments about A. So sum the moments about A equals, that equals, and I'm just going to do that, the rectangle first. So that was what we found to be 3,600 newtons. It's going to give a negative moment. We're going to send the out of the board is positive. So negative 3,600 newtons times 3 meters. And then minus that 375 newtons times 1 meter. And that's going to equal that resultant force times the distance. So that equals, I'm just going to calculate that out. Um, 11,175 Newton meters. And then we just need to divide that by that resultant force. And that was that we found to be 3,975, so that equals 11,175 over 3,975. And that equals 2.811. So that's going to be that distance. So that's 2.81 meters was the solution for that one. Was that distance for question 8? And write question 8. Let's see. Oh, I keep going back to blue or to red. Anyways, so that's question 8. So question 9. What is the appropriate equation for the sum of the moment about B equal to 0? You could either just solve it just by hand and then try to find it in the options. That's probably the easiest way to do it. So question 9, so the moment, what's going on? It's hard, so I'm trying to write without touching the board. So it's a little sloppy, I apologize for that. The sum of the moments about B equals 0, and we'll do out of the board is being positive. So with that, we need a free body diagram. I knew why this was doing that. So at A, let's see, we have AX. Sorry, this is almost unusable. Nope. Not sure what to do here. So draw a free body diagram. So this whole system, we have AX, AY, we've got 10 kilonewtons, 6 kilonewtons, and then 8 kilonewtons up here. And then we also have some of the dimensions. Sorry, this is so sloppy, but I'm trying to not touch the screen so it doesn't do that weird skipping thing it's doing. 4 meters. So each of these are 4 meters. This is where point B is. And then this height here is 3 meters. So the sum of the moments about B are going to equal, let's see, AX isn't going to create a moment, AY will, and that'll be in the negative direction, the way I have it drawn here, negative AY times 12 meters, then plus 10 kilonewtons times 8 meters, then plus 6 kilonewtons times 4 meters, and then minus 8 kilonewtons, so I'm doing this one up here, times that perpendicular distance, so there's 3 meters, and that equals 0. So let's see which one of these corresponds with that. So we have, let's see, negative AY times 12 meters plus 10 kilonewtons times 8 meters plus 6 kilonewtons times 4 meters, and then minus the 8 kilonewtons times 3 meters. So that would be option 5. And probably if I was taking the test, I would look over that one more time. So go, okay, negative AY times 12 meters plus 10 times 8 plus 6 times 4 minus 8 times 3. It would have been okay if you had drawn that AY in the other direction. This would have been different, but the others would be the same. Or if you'd done, positive being into the board, but this is the only option of those 5 that actually is a valid option. So that's the only one that's an appropriate equation for that. For question 10, you're supposed to solve for BY. So 10. So for BY, what we can basically do is we can sum the moments about the A. We could either sum the moments about A, or we could solve that equation we just did and then just do some of the forces in the Y direction. Yeah, maybe we'll do that. Might be easier. So let's solve that equation first. So we get negative 12AY, and then 10 times 8 plus 6 times 4 minus 8 times 3. That's 80, so that equals negative 80. So AY equals 6.67 kilonewtons. If we sum the forces in the Y direction equal to 0, we'll get that AY, which was 6.67 minus 10 minus 6, and then that 8 is just in the X component, and then plus BY. I guess we should have that drawn on here too. So BY equals 9.33 kilonewtons. And it said use at least 2 significant figures. Then for the last one, we're given the problem and then also a free body diagram, so we may as well use that. And we need to figure out which equation can be used for that sum of the moments about the x-axis equals 0. So looking at the free body diagram, we have that 200 Newton force is in the x direction, so that wouldn't create a moment. We have the 300 newtons, which would create a moment, which would be in the negative direction. So let's see, this is problem 11. Negative 300 newtons, and that's 2.5 meters from that x-axis. And then we also have that 500 Newton force, which would create a moment, which would also be in the negative x direction. So negative 500 newtons times 1.25 meters. And then we also have, for the moment about x, is that max that's written down at the bottom. So plus max, that equals 0. And then we just need to look at the question. So we have max for options 2 through 5, so it's one of those. Minus 500 times 1.25, so it'll be option 2 or 4. And then minus 300 times 2.5, minus 300 times 2.5, so it would be option 2. So that's it.